Hello, pirates. Today we're going to talk about molarity. Molarity is simply a way of measuring how strong or weak you want to make a solution, or how concentrated or dilute you want to make a solution. You've heard me say all year that chemistry is a lot like cooking, and it's very true. In cooking, we might measure our ingredients with teaspoons or tablespoons. You might add a teaspoon of salt to a cup of water for a recipe. Similar to cooking, in chemistry we need to make solutions, but we need to know precise amounts. We don't use teaspoons. We measure moles per liter. Since we're all at home right now, we're going to use ingredients that we can find around the house. Today I'm going to be using sugar, which the main ingredient is also known as glucose, and the molecular formula is C6H12O6. Now this is important because we're going to have to find the molar mass of glucose. So the mass of 6 carbons, 12 hydrogens, and 6 oxygens comes out to be 180.156 grams, and that is the molar mass. There are this many grams in a mole of glucose. This means to make a 1 molar, the big capital M is how we abbreviate molar. To make a 1 molar glucose solution, I would need 180.156 grams of sugar. And then after I add the sugar to a container, I would fill the container up to the 1 liter line with water. And then I would dissolve it to make my solution. But we're at home, so we're going to adjust these volumes a little bit. I'm not going to make a liter. I'm going to make 1 cup of the following solutions. I want a 1 molar concentration, a 0.1 molar, a 0.4 molar, and a 0.8 molar. So we've already said for a 1 molar solution, if I'm going to make 1 liter, I need 180.156 grams. But we're going to make a cup, not a liter. So we're going to have to do a little conversion. Now, if I ask Mr. Google, he'll tell me that there are 236.59 milliliters in a cup. But I need to know how many liters are in a cup. Do you remember our metric conversion shortcut, King Henry? This stands for King Henry died by drinking chocolate milk, which stands for kilo, hecto, deca, base unit, deci, centi, and milli. Okay, there are 236.59 milliliters. So here's my M. I marked it blue. That's where we're starting. And I want to go to the base unit, which would be regular old liters. To get from milli to liters, liters is 3 spaces to the left of milli, so we're going to move our decimal 3 times to the left to convert from milliliters to liters. So this means 236.59 milliliters equals 0.23659 liters. Now we can set up a proportion. On the left side, I have my molar for 1 liter of a 1 molar solution. On the right side, we have our liters we just found on the bottom, and then we cross multiply and divide to find out for 1 cup of a 1 molar glucose solution, I need 42.62 grams of sugar. So to create the solution, first I'm going to weigh out 42.62 grams of sugar. Then I'll put that in my measuring cup and fill the measuring cup to the 1 cup line with water. You want to add the sugar in first because you want to make exactly 1 cup of solution. If you put the water and then the sugar, you will end up with more than 1 cup of solution. Okay, I'm at home and I'm using my kitchen scale. It doesn't really go to the tenths and 100ths of a gram, so I'm going to have to round a little bit. Tearing out the measuring cup first, or zeroing it out. And then it's going to take me a minute to get as close as I can to the amount I need. So I'm going to fast forward just a little bit. Okay, that's as close as we can get. 43 grams is close to the 42 point something something. And then I'm putting it in my measuring cup. I'm kind of a big deal. You all know I love pickles. Okay, I'm going to add the water up to the 1 cup line to make 1 cup of solution. And then I'm going to stir to dissolve very, very well. So lots and lots of stirring later, got it pretty well dissolved. And this is organic sugar, it's why it's not exactly white. But you can see that there's a lot of sugar dissolved in this. This is the 1 molar solution. You do a little bit more dissolving. Should have used warm water. That would have helped it dissolve faster. And we're going to set that aside for now. Next, we'll be creating a 0.1 molar solution. And this one's going to be a lot easier to convert because I already know that 1 cup of a 1 molar solution uses 42.62 grams. So if I want to make 1 cup of a 0.1 molar solution, I'm going to multiply my grams by 0.1. I need 4.262 grams. Now my scale doesn't go to the decimal places, so I'll get as close as I can with 4 grams of sugar, and then fill the line up to the 1 cup line with water. Okay, I'm going to get as close as I can with my scale, so there's 4 grams. Okay, put that in the measuring cup, and then I'm going to add my water. I only want to fill it up to the 1 cup line to make 1 cup of solution, and then I'm going to stir to dissolve it. Lots of stirring later, it's pretty well dissolved, and you can kind of tell there's a big color difference in these solutions. Okay, so that's the 0.1 molar compared to the 1 molar. My next solution is going to be a 0.4 molar solution. So I'm going to take the original amount, my 1 molar needed 42.62 grams, times 0.4. Say that I need 17.048 grams for 1 cup of a 0.4 molar solution. Okay, I'm going to get as close as I can, so 17 grams into the measuring cup. I'm going to add my 1 cup of water and stir, 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 stir. Lots of stirring later. Oh, there we go. Into the glass. And it's still pretty clear, but you can kind of tell it's a little bit darker than the 0.1, but definitely not as dark as the 1 molar. There, our final solution. My final solution is going to be a 0.8 molar solution. So I still take the amount from my 1 molar, my 42.62. This time I'm going to multiply it by 0.8. So I'm going to need 34.096 grams to make a 0.8 molar solution. Remember, we're only making 1 cup of solution. So I've got to get my 34.096 grams and add water up to the 1 cup line. Getting as close as I can with my scale. I've got 34 grams of sugar. I'm going to add my water up to the 1 cup line again and stir it until it's dissolved. Okay, so it's almost dissolved. There we go. And you know what? I think you're kind of a big deal too, and I miss you guys. Oh my gosh, you have no idea. All right, so that's my 0.8 molar solution. Let's compare these all side by side. Okay, so here's all 4 of my solutions. If we start on the right side, that is my 0.1. Don't mind our boxes over there. All right, so 0.1, 0.4, 0.8, and 1. You can tell the difference between these solutions. They're all sugar and water, but look at the concentrations. On the far right, I would call that very dilute. It has a little bit of solute dissolved in solvent. On the far left, we would call that concentrated. It has a lot of solute dissolved in the solvent. So these solutions are all made out of the same ingredients, but they have different molarities because they have different molar amounts in the solution.